All right, this next problem has a figure that's a similar shape to the track, but it's giving us some different information and asking us to find some different information about the problem. So this is a window, and the window is made up of a square and a semicircle. And the only information we're given about that window is that the total area is 525 square inches. And the total area is made up of the area of a square and the area of a semicircle. Right? So part A asks us to write an equation for the total area of the window. So the area of the window is going to equal the area of the square plus the area of our semicircle. Okay. Well, we know that the area of the window is 525 square inches, and we know that the area of a square is just length times width, so x squared in this case. Area of a semicircle, we're going to have to jog our memories and remember that the area of a circle is pi r squared. So the area of a semicircle, which is just half of a circle, right, of a semicircle must be half pi r squared. Okay. But r is not going to help us here, right? Because if we're thinking about using a calculator or solving for the side length of the window, which is eventually what we're going to have to do, we're going to need everything in terms of x. Okay, so if we look at our semicircle here, and we know that r is half is the radius, right? So if this is r, well, what is r? R in this situation is actually 1/2 x. Okay, so we're going to need to take this r and substitute it into the formula for the area of a semicircle over here. Okay, so we're going to have half pi r squared. So r is 1/2 x, and we're going to have to square all of that. Okay, so again, the half pi r squared is the area of a semicircle. This guy here is r. Okay, so let's simplify this a little bit. I'll go over here to help simplify. So half of x squared, right, is, I have to square the half and square the x. So half of x squared is 1/4 x squared. And then the half pi, I'm going to just leave the pi out for now. It's going to come along for the ride. But half times 1/4 x squared is 1/8 x squared. So this entire thing is going to boil down to 1/8 pi x squared. So we have 525 equals x squared plus 1/8 pi x squared. Okay, and at this point, we can grab our calculators and find basically the intersection of x squared plus 1/8 pi x squared and 525. Right, so we would graph those two things, which I'll do in a minute, and find the intersection point or points. But we could also just solve this algebraically because we've got we have like terms here. I mean, it's a little ugly, but we do have like terms. So I'm going to just go ahead and solve it algebraically, and then I'll show you what it looks like when we graph it. Okay, so again, this problem's a little different. We're not maximizing area. We're given area, and we're being asked to find the side length of the square. Okay, so the first thing I'm actually going to do is multiply the entire equation by 8 to get rid of that fraction. I mean, you don't have to do that, but it just makes it a little bit friendlier. I have 25 times 8, so we have 4,200 equals x squared, 8x squared, sorry. 8x squared plus the 1/8 is going to go away, pi x squared. And now we could factor out the x squared, 8 plus pi, and then divide everything by 8 plus pi. And that's, of course, not pretty, but I'm just going to leave it like that. 4,200 over 8 plus pi is equal to x squared, which means if I want x, I'm going to have to take the square root of both sides. So x is equal to the square root of 4,200 over 8 plus pi. Again, not very pretty, but we can certainly do that calculation. So 4,200 divided by a plus pi and take the square root of it, it looks like that is approximately equal to 19.4. So now we can go over to our graphical method and just double check that we did that calculation correctly. All right, so we can see here, this is the graph of x squared plus 1/8 pi x squared. All right, and I'm looking at it on the positive side because I don't really care about what's happening on the negative side, because we know that the dimensions of our window are never going to be negative. And I've increased my x, or I've changed my, I've made my y scale go up to 600 because I want to know what's the value of x, right? What's the length of the window when the area of the window is 525 square inches. So I can graph y equals 525, and you can do this all in your calculators as well, and then find that intersection point. And that intersection point, as expected, has a y value of 525, but here's our 19.4, excuse me, that we got when we did just the calculation by hand. So again, either way, the algebraic method or the graphical method works fine for this problem. And then finally, part C is asking us for the perimeter of the window. Hopefully I don't run out of room here. I'll kind of squeeze this in over here. Part C is asking us for the perimeter of the window. Okay, so the perimeter of our window is going to be, if we go around, we've got 3 x's, right? 3 sides of the square on our perimeter, and then half of that circle. So 3 x's plus half of our circumference of the circle, right? So 1/2 pi d, right? That circumference formula was from the last problem, pi d, but pi d in this case, our diameter is x, right? So half of pi times x. And then you have an x value, so you can just plug that right in. So we've got 3 times 19.4 plus half times pi times 19.4. So 3 times 19.4 plus a half pi times 19.4, and I just did the quick calculation on my calculator, and it looks like it's about 88.7 inches. So again, this problem is just really asking you to use that value of x and find the perimeter of your window. Again, the perimeter of the window is made up of 3 sides of the square and half of the circumference of the circle. Circumference of the circle being pi times diameter. The diameter of this whole circle is x. So half of the circle, half of the circumference would be half pi times diameter.